Hey folks, it's Bass Action, back in action here. We are going to look in this set of notes at how to write intervals using our interval notation as opposed to the inequality notation you would have used in your prior classes. And then we're also just going to quickly review a few basic equations from Algebra 1, Algebra 2, and then some quick graphical symmetry analysis. So jumping into our interval notation, the first thing that we want to take a look at is how we would have written things in the past. So up at the top of our notes here, it's important to note that our intervals are always going to be written from low to high. We're going to have two types of intervals here, and we're going to have bounded intervals. A bounded simply means that they are going to have a beginning and an end. Okay, so we'll have a beginning and an end to each of these. When we get to our notes partway down the page here, we'll have some unbounded intervals. Those will go forever in one direction and or the other towards infinity. So let's first look at what we would call a bounded open interval. And the bounded open interval simply means in our former experience we would have had a less than or a greater than, but not inclusive. So when we think of our former notation translating to a number line, you would have put those on a number line with open circles. What we're going to see now is those open circles will translate to these parentheses, these curved parentheses. Other than that, it looks very much the same as what you would have done in your Algebra 1 courses. You put your numbers on the number line and indicate the set of numbers in between. A closed bounded interval instead is going to have an equality on there. So instead of just less than or greater than, it's going to be a less than or equal to or a greater than or equal to. Those inequalities are going to translate from our Algebra 1, Algebra 2 courses to solid dots on the number line. And for our new notation, we'll translate to these square brackets. We can have what's called a partially closed bounded interval. So we'll have these maybe an open and an equality. So our open would be our open circle, which would translate to our parentheses. Our inequality with the inclusive here would translate to our solid dot, which would then translate to our square bracket. The only thing to add here then in terms of our unbounded intervals, when we do those, I think it's always important to indicate that we're going to be using our infinity symbols. It might take a little practice for you guys to write those. And the important thing that we want to pull out here is that our closed brackets will never be used with our infinity or our negative infinity. So for example, if we have this x is greater than 6, we can see this on our number line. Now there is a small typo on this page here that I want to call your attention to. This should actually say greater than or equal to there. That's just an error on my part, so you'll want to fix that. So when we go ahead to translate this to our number line, we have our solid dot for our greater than or equal to, and then we would indicate forever in this direction. Now, I always encourage my students to go ahead and actually write the infinity symbol on that end, because then those numbers can just pull to our interval notation. Solid dot becomes the square bracket. The infinity will always become a parentheses. Just continuing on the next problem here, I always tell students fill in that negative infinity. Of course, you can see that that pulled our less than or equal to became our solid dot, and it pointed in the negative direction. And from there, we just have our parentheses for the negative infinity and our square bracket because of our solid dot. Our all real numbers that in our past, what we would have written as is the R with the two vertical lines. What we're going to do instead is indicate that this is our entire number line, and then we can just translate that to our interval notation. Okay, so that's all that we've got there for interval notation. A couple other things that we want to briefly review here, the equations for our lines. So we have a point slope form of a line, which is going to be very important for us. So we're going to have our y minus our y sub 1 and our slope indicated as m, and our x minus x sub 1. Remember that this m is our slope, so whatever you know the slope to be, and then the y sub 1 and the x sub 1, that's going to be any point on the line. The next one would be our slope-intercept form. This is the one that students are most familiar with, our y equals mx plus b. And again, our m is our slope, and our b is specifically the y-intercept. It is important that you be able to use whatever form is going to be the most convenient for the problem. You don't want to have to always be switching from one form to the other. General form, our ax plus by equals c. This one isn't used as frequently, but it is pretty convenient to find our x and our y intercepts because we just let x equal 0 and or y equals 0. So this one doesn't have as much, but we could indicate that the x-intercept, if we solved this, if we let y equal 0 and solved for the x, we would get the x-intercept will always be c divided by a. Our y-intercept is going to become our, if we're letting x equal 0, would become our c divided by b. So those are really the most convenient things that we have there. We could also indicate that if we wanted to solve for the slope, imagining that we solved this equation for y, so it turned into our slope-intercept form, what we would end up with is a slope being a negative a over b. So that's not super common, but it is good to know. Okay, turning the page, we can go ahead and just quickly write our formulas here. So we've got our distance formula. Remember, distance formula is really thought of as the Pythagorean theorem. We'll see that here in just a little bit. So we're going to have our x sub 2 minus our x sub 1 quantity squared plus our y sub 2 minus y sub 1 quantity squared. Our midpoint formula, we're simply going to add the two x values, x plus 1 and x sub 2 over 2, and our y sub 2 plus our y sub 1 over 2. And our slope is going to be the difference in our y values, y sub 2 minus y sub 1, divided by x sub 2 over x sub 1. This is also often referred to as a change in y and a change in x. That triangle mathematically means change. So it's a new symbol for you, probably. For most of you, that triangle means change. And then we often just think of it as rise over run. So any of those are good. The next thing we want to look at is some quick formulas related to our distance formula. So just kind of thinking where these formulas come from. On our distance formula, if we envision this as a nice right triangle, and we think of this point up here, let's say, as x sub, we can call it 2 or 1. I'll call this top one x sub 2 and y sub 2. And this point down here, we're going to call x sub 1, comma y sub 1. Then what we can think of then as the distance between these 2 points, we can label these two sides. We can take the difference between our two x values, thinking on our Pythagorean theorem. So we would have an x sub 2 minus x sub 1. And then again, we can think of the difference between the two y values for the vertical piece on that triangle. So we'll have our y sub 2 minus our y sub 1. Now if we just think in terms of Pythagorean theorem, we would have d squared, the hypotenuse squared, and we would have our two legs, x sub 2 minus x sub 1 squared, plus y sub 2 minus y sub 1 quantity squared, which of course solving for that hypotenuse gets us that distance formula that we were trying to achieve, x sub 2 minus x sub 1 plus y sub 2 minus y sub 1 squared. So if you're ever struggling with trying to remember whether you should add or subtract or how this should work, just think of it in terms of a triangle. The midpoint formula we of course want a point, and I think that's an important thing to remember in our name, is that it's a midpoint or a middle point. So if we've got our 2 points here, x sub 1 and y sub 1 and x sub 2 and y sub 2, if we want the middle point, just think of this in terms of an average, okay? So if we just think average, it's pretty easy to remember what we do for midpoint. We add together the two x values and divide by 2, and we're going to add together our, let me erase that real quick. Sorry, I meant for that to be a 1 there. It doesn't matter really the order that we use, but they should be consistent. So a y plus 1 plus a y sub 2 over 2. And that's, of course, a point. Okay, so that's just a quick review of those basic formulas. The next thing that we want to take a look at, the last thing, this might be new, is in terms of symmetry. So I've got a couple pictures here for you to help you kind of see these symmetries and what's happening as we reflect points over our x-axis. So what we can see on this first picture is that when we reflect things over the x-axis here, that the x value stays the same, but the y value changes its sign. So if we kind of think of this in terms of an actual example, work simultaneously, if we come down here, we've got this point on our coordinate grid here, that's the point 3, 2. If we want to reflect this point over the x-axis, we're going to keep the 3, but we're going to change the y value to a -2. So our x-axis symmetry would be the point 3, -2. Next thing we can take a look at is that if we've got y-axis symmetry, we now can see that the y values are going to stay consistent, but the x value is going to change its sign. So if we take a look at our point we were just working with here, our point 3, 2, if we want to reflect that point across the y-axis, we need to keep the y value the same, but we need to make the x value now negative. So our y-axis symmetry is going to be a -3 and a +2. The last thing that we're going to take a look at is moving or rotating a point with respect to origin. So if we have the point xy and we rotate it around, both the x and the y are now going to change signs. So the last one, if we take our point 3, 2 and we want to reflect this around origin, both the 3 and the 2 need to change signs. So -3, -2 puts us right here. So -3, -2. So that's all that we've got in terms of our quick algebra review, and then a brief step into our graphical symmetry.